Footing design. Introduction. Footings are structural members used to support columns and walls and to transmit and distribute their loads to the soil in such a way that the load-bearing capacity of the soil is not exceeded. Excessive settlement, differential settlement, or rotation are prevented, and adequate safety against overturning or sliding is maintained. Footing details. We have the dimension of the footing and the column at center, and we have the matting for both ways and the connection from column to footing and the thickness of the footing. Design of a footing typically consists of the following steps. First, determine the requirements for the footing, including the loading and the nature of the supported structure. Number 2, select options for the footing and determine the necessary soils parameters. This step is often completed by consulting with a geotechnical engineer. And number 3, the geometry of the foundation is selected so that any minimum requirements based on soils parameters are met. And for the types of foundations, first, shallow footings, barely directly on or bear directly on the soil supporting soil. This type of foundation is used when the shallow soils can safely support the foundation loads. Next, a depth foundation may be selected if the shallow soils cannot economically support the foundation loads. Deep foundations consist of a footing that bears on piers or piles. The footing above the piers or piles is typically referred to as a pile cap, and the piers or piles are supported by the deeper competent soils or are supported on bedrock. It is commonly assumed that the soil immediately below the pile caps provides no direct support to the pile cap. And for the types of footings, first, isolated or single footings. These are common footings construction or building construction are used to support single columns. This is one of the most economical types of footings and is used when the columns are spaced at relatively long distances. Next, we have wall footings are used to support structural walls that carry loads for other floors or to support non-structural walls. And this is the example of a wall footing. We have the foundation or the footing, and instead of a column, it is a wall or a concrete wall. And if you have two columns that are nearer to each other, we can use the combined footings. Usually support two columns or three columns not in a row. Combined footings are used when two columns are so close that the single footings cannot be used, or when one column is located at or near a property line. So we have two columns that is near with each other. If we combine the footing from the left and the footing from the right, individual or using isolated footings, there will be overlapping of concrete. So that's why we can use the combined footings. Cantilever or strap footings consist of two single footings connected with a beam or a strap and support two single columns. This type replaces a combined footing and it is more economical. This is the footing from the left side and another footing from the right side, and we have a strap beam. Next, continuous footings support a row of three or more columns, which means more than three columns. We can use continuous footings. They have limited width and continue under all columns. So this is the width of the footing, and we have four columns connected as continuous footings. Rafted or mat foundation consists of one footing usually placed under the entire building area. They are used when soil bearing capacity is low. Column loads are heavy single footings cannot be used, and piles are not used, and differential settlement must be reduced. And that's mat foundation. Pile caps are thick slabs used to tie a group of piles together to support and transmit column loads to the piles. So these are piles and this is the column. And above the piles is the pile cap. The following steps are typically followed for completing the structural design of the footing or pile cap based on ACI, American Concrete Institute 318-05, that determine footing plan dimensions by comparing the gross soil bearing pressure and the allowable soil bearing pressure. And number 2, apply load factors in accordance with ACI 318-05 and determine whether the footing or pile cap will be considered as spanning one way or two ways. Confirm the thickness of the footing or pile cap by comparing the shear capacity of the concrete section to the factored shear load or shear load. ACI 318-05 provides guidance on selecting the location for the critical cross section for one-way shear. ACI 318-05 provides guidance on selecting the location for the critical cross section for two-way shear. Determine reinforcing bar requirements for the concrete section based on the flexural capacity along with the following requirements in ACI 318-05. First, requirements specified to footings or specific to footings. Number 2, temperature and shrinkage reinforcing system requirements. Number 3, bar spacing requirements. Number 4, development and splicing requirements. Or number 5, seismic design provisions and other standards of design and construction as required.